Hello, my friends. Welcome back to our AI A to Z course. Today is for all of us, AI for the fair minded. I am Dr. Sonali Tamankar, and we are talking about B is for bias in AI. Let's start with a mystery. Consider an AI algorithm trained to classify wolves versus dogs. So you show it a picture and it has to say wolf or dog. Such algorithms are trained on thousands of photos or training data with corresponding labels as dogs or wolves. So the AI model got really good at this, except it made some mistakes. Specifically, it kept confusing huskies for wolves. Why do you think this might be? Well, a 2018 paper titled Can Everyday AI Be Ethical gave us the answer, and it's fascinating. If you or I were asked to classify dog versus wolf, we would look at the animal, right? But the AI, it was looking at the background. It noticed that almost all the wolf photos had snow in the background. So it learned a shortcut. If there is snow, it's a wolf. It wasn't looking at the animal at all, it was looking at the scenery. So now, before we laugh at the AI, we need to look in the mirror. Now, imagine a hiring manager. We humans do the same thing, right? So, a hiring manager who sees a candidate with tattoos all over and pink hair, if they immediately think unprofessional, they are doing exactly what the AI did. They are judging on the background noise, the tattoos, rather than the actual signal, which is the candidate's talent. So we call this proxy bias. Just like the snow is a bad proxy for wolf, appearance is a bad proxy for competence. So we're judging the book by its cover, so to say. Right? Now, here is the scary part. If one hiring manager has a bias, maybe the job prospects of a handful of people are affected. But if an AI algorithm adopted by a big company has a bias, millions of people can be affected instantly. So, this is the central warning of the award winning book, Weapons of Math Destruction by Kathy O'Neill. She warns that AI models are often like black boxes. We don't always know how they decide, but they do decide on a massive scale. So, take for example facial recognition. The documentary Coded Bias highlighted the shocking research showing that some systems had error rates of up to 35% for darker skinned women compared to less than 1% for lighter skinned men. Why? Because the training data was insufficiently representative. It was mostly lighter skinned faces. So now this is not just a harmless glitch, that's a civil rights issue. Would you want your face confused with that of a wanted criminal? So let's move on from that scary thought to another scary thought. Bias isn't just about what AI sees, it can also be about what AI shows you. So, this brings us to confirmation bias. Imagine you click on one video about a fringe conspiracy theory, maybe just out of curiosity. The AI notices this and thinks, aha, they like this. So, they serve you another one. You click again because it's right there in front of you. Pretty soon, your entire feed is an echo chamber of extreme views. The AI is confirming your interest and pulling you down this rabbit hole. So this tears at the fabric of our society, right? Instead of a shared reality, we end up living in customized truth bubbles, all because the algorithm was trying to maximize your watch time. Okay, so now that we are in the age of ChatGPT and LLMs, let's ask how representative are these? Right? So there is a fascinating paper called Which Humans that maps AI models against human values from around the world. Incidentally, they used a technique called hierarchical clustering. We'll talk tomorrow about it in C's for clustering. But look at this chart. So, where does GPT land? It sits here right next to Germany, and the paper finds it to be close to the US. So, it's deep in the center in this cluster of rich Western countries. So, it doesn't speak for the whole world. And that makes sense. Almost half of the world's population, like 3.6 billion people, are still offline. So if they aren't on the internet, their voices aren't well represented in the training data. So we see this theme again. If the training data is not representative, AI tends to be biased. We saw several examples of this. As a healthcare data scientist, this next example is especially close to home for me. Consider this scenario. We want to use AI to assign risk scores to patients so we can prioritize those who need extra help. So, a landmark study by Obermeyer et al. Found that a widely used algorithm was heavily biased against Black patients. So, at the exact same risk score, Black patients were actually much sicker than the white patients. Now, same risk score is supposed to mean the same severity of sickness, right? So, how did this happen? So, AI was told to predict healthcare costs as a proxy for sickness. The logic makes sense, right? Like if someone is sicker, they'll maybe see the doctor more and spend more money, right? But in the US, access to care depends not just on how sick you are, but your insurance and your wealth, right? So less money spent didn't necessarily mean less sick. It often just meant less access. So AI learned to prioritize those who could afford to pay rather than those who really needed the help. So these AI biases are subtle and very real. But the good news is carefully designed algorithms can go a long way in mitigating them. And a lot of people are working on this. The NIH All of Us program is building a diverse healthcare data set. I'll put all these links in the description below. NIST, or National Institute of Standards of Technology, and EU laws provide a framework for trustworthy or responsible AI. CHAI, group like CHAI, Coalition for Health AI, are joining the conversation specifically in the healthcare domain. So sometimes fixing the AI bias is as simple as adding a few lines of code to rebalance the data, if we care enough to do it. So the takeaways today are: computers will do what you ask. They'll solve the problem mathematically as posed. So it is up to us to include guardrails. AI will mirror the training data, which includes societal biases, and using biased AI can amplify inequities. However, there are many organizations and approaches that can help us in designing ethical and responsible AI systems. So that's it for today. What questions and comments do you have? Please comment below, and we'll keep chatting. See you tomorrow for C is for clustering. Thanks. Bye.